This is a tape path check using a very thin tape. Let me see how many micrometers it is. Probably not given here, but this is a 120-minute tape, so it's very thin, so very easy to curl. So if your pinch rollers and then the capstans are not up to the task, then it's very easy for the tape to curl up and then make a mess. So this is like the ultimate test. I mean, the ultimate test is actually spooling this side free and then see if the tape spills, or because if there is no back tension, then there is no tautness in the tape, so it's easy for the tape to spill in those moments. Let's start the test again. There should be no wandering. The surface of the capstans is matte and the pinch rollers are nice and matte. And so the pinch rollers, they all they do is pinch the tape. If there is any dirt or grime or the friction is not right, then the tape will just curl up, because it's like a few microns. Remember, if it's few microns, it's very easy for the tape to just curl up and make a mess. It's a pretty fascinating physics if you actually probably draw a free body diagram and then analyze what kind of forces are here. So on the right side, you see it's called the take-up capstan, and the left side is the supply capstan. This is a dual capstan, meaning tape, the dependence, the shell dependence is not at all here, the cassette shell, because the tape is being pulled by the take-up capstan on the right, and then tape is being pushed by the supply capstan. So there has to be a proper tension difference between them for the head to be taut on the head, for the tape to be taut on the head, for the high frequencies to be captured properly. If not, there will be an issue. So that's called intercapstan tension. So this is one of the very difficult test tapes. It's very easy for the tape to spill and make a mess in these kinds of with these kinds of test tapes. So if it was a single capstan, there is only pulling, meaning if there are any irregularities in the shell, it will show up in the tape path, because the tape will be wandering as per the irregularities. But for a dual capstan, it is isolated. The tape path is isolated on the head. So one side is pulling, one side is pushing. It's a very gentle dance. If it is not done properly, then it's a mess. That's why dual capstan decks can be a little bit challenging. They give perfect or near perfect azimuth accuracy, as opposed to single capstan, which is constantly, if the tape was not wound properly, a single capstan can easily change the azimuth as the tape is being released from the left side. So another test I wanted to show was measurement of torque for forward fast forward, rewind, and say if you press play, I mean, you're not supposed to test this using this, play tension or the take up tension using this cassette. I have another one that I'll pull up now. Hold on a moment. So this is a TIAC MTT811. This was made for measuring playback and back tension. So playback is on the right side. It's called take up, and then the back tension is on the left side, on the supply side. So back tension is just tautness applied to the tape as it is being released from the left side, or else it can wander on the supply side capstan and then making a mess. So anybody who dealt with conveyors or belts in industries can know, like, it makes sense to have some kind of a tautness on the supply side if you want the belt to be on the pulley. So let's see how it does now. So the spec was for 50 grams centimeter for the take-up side, and the back tension is 8. We are there, so there is some back tension here. Single capstans don't have any back tension because they don't have a supply side capstan and the pinch roller, so you don't need back tension there because there is no isolation from the shell. So yeah, that's all.